Hey everyone, myself Bhavya Goyal, a student at IIT Gandhinagar. I welcome you at CodeChef and let's have a look at this question. Today's question is ARRGRAPH. So in this question, we are given an array A of size n and we create a graph from this array A which consists of n vertices by adding the bidirectional edge I comma A of I for each I in between 1 and n. So let's say this is our array A and all the elements of the array are in between 1 and n. So we have an array of size 6 and all the elements are in between 1 and 6. Now we can generate a graph from this first array by connecting each A of I with I. So these are the I's and these are the A of I's that we have. So we are connecting 1 with itself. So basically it is just 1. Then we are connecting 2 with 3. We are connecting 3 with 2. We are connecting 4 with 5. And we're connecting 5 with 4, and then we're connecting a 6 with 6. So there are 4 components in total in this graph, right? In the graph generated by this array. Now we are saying that an array is good if the whole graph that we got is connected. So is this graph good or not? It is not good, right? Because the graph that we got is not connected. Now let us try to generate the graph for this array. So we'll be connecting 1 with 2. We'll be connecting this. I'll just write the numberings first. So we'll be connecting 1 with 2. We'll be connecting this 2 with 3. We'll be connecting this 3 with 4, this 4 with 5, this 5 with 6, and we'll be connecting this 6 with a 1. Now, is the graph generated by this array a good one? And yes, it is. Why? Because this is a single connected component, right? So we need to find a rearrangement of the given array A such that the rearranged array is good. Or we need to print -1 if it is not possible to find any such array. Right. So if this was the initial array given to us, we could have printed this rearrangement and that is a perfectly written answer. Right. Now let us quickly see the constraints. And the constraints are given that number of test cases would be in between 1 and 10 is equal to 4. N would be in between 2 and 2 into 10 is equal to 5. A of 5 would be in between 1 and 10. And the sum of n over all the test cases will never exceed 2 into 10 is to the 5. Right. So the expected time complexity that we can have would be of order of n or something like of order n log n. Right. This is pretty much the problem statement and the constraint. Now let us see a few sample inputs to understand it better. So in the first input, this is the array given to us, which is 1, 2, 3. And the graph generated by the initial array is this, right? So this is not a good array, obviously, right? So our answer is this, where we have printing 3, 2, 1. Now the graph generated by this array is 1 is connected with 3, 2 is connected with 2 only. Right, so this is 1, this is 2, okay, this 3, 1. Right, so 2 is connected with 1 and 3 is connected with 2. So this is a single connected component, hence it is a good array. And the other test case that we have is 3, 1, 1, 1. So in this case, 1 is connected with 1. So 1 is connected with 1, 2 is connected with 1, and 3 is also connected with 1. So this given array is already a good array, and hence we have simply printed this array. Right. So this is pretty much a problem statement. Now let us move to the solution. So in these kind of constructed question, it's usually best to just dry run a few cases and try to create some answers for them. So let us try for these arrays, right? So let's say, let's first of all consider an array where all the elements are distinct. So if all the elements are distinct, that means it will be a permutation of the elements from 1 to n, right? Why will it be a permutation? Because all the elements are in between 1 and n, and all the elements are distinct. So we are given, let's say, something like this. So what can we print? Oh, one possible solution is to just simply print 2, 3, 4, 5, 1, which will give us a cyclic, right? As we considered above as well, right? So this is what we'll get if we just print like the first cyclic permutation, right? So like we just sort the whole permutation. So let's say if we had 3, 1, 2, 4, 5, we could just take in the input of the whole array. We could just sort it and then just rotate it once. So we'll have 2, 3, 4, 5, 1, and we can simply print it. And that's a perfectly valid solution, right? Similarly, for like if it is of 6, we can like first of all take in the input of the whole array. Let's say it was somewhere by 3, 2, 1, 6, 5, 4. Let's say this was the array. We could have taken in the input of the whole array So we took and then put out 3, 2, 1, 6, 5, 4. We sorted the whole array, so we'll have 1, 2, 3, 4, 5, 6. And then we can just rotate it once, so we'll have 2, 3, 4, 5, 6, 1. And then we can simply print 2, 3, 4, 5, 6, 1, and that is perfectly valid, right? Because 1 is connected with 2, 2 is 3 with 3, 2, 3 with 4, 4 with 5, 5 with 6, and 6 with 1. So we'll again have like a graph like this, right? So this is the graph that we'll get, which is exactly connected and which is perfectly valid, right? Now let us consider the cases when we can have some duplicates, right? So let us say this is the type of graph that we have. So what are the distinct elements that we have? We have a 4, a 2, and a 5. Right. So we can again sort this whole array. So we'll have a 2, a 4, and a 5. Right. So can we again like create a cycle of at least these three elements? So we'll have a 2, a 4, and a 5. Right. We can easily create a cycle, right? How can we do that? So on the index 2, we'll put in a 5. On the index 4, we'll put a, sorry, on the index 2, we'll put this 4. On this index 4, we'll put this 5. And on this index 5, we'll put a 2. So 2 is connected with 4, 4 is connected with 5, and 5 is connected with 2. So we'll have a cycle like this, right? Now, what about the rest of these elements? Can we just put an anything over there? Or can we like just keep them unchanged? So we have what we had 4 here, so we'll keep a 4. We had a 2 here, we'll keep a 2. We had a 5 here, so we'll keep a 5. And will it still be connected? Yes, always it will still be connected. Why? Because all of these elements would be connected with one of the elements in this cycle, right? Because if it is not, that means it's a distinct element. And if it's a distinct element, that means this would have been a bigger circuit, right? So in this case, what will happen? We'll connect this one with this 4. We'll connect this 3, this 2 with this 3 with this 2. And we'll connect this 6 with this 5, right? And this is the graph that we'll get. And this is again perfectly valid, right? And yeah, this is pretty much the whole solution. So what we can do, we'll just first of all collect all the distant elements, sort them, and just put in the values of one cyclic rotation. And then for the rest of the elements, we can just put in everything, right? So 4 to 5 is one possible thing. We could also have put like 2, 4, 5 over here. And that is also valid, right? Now let us see the time complexity. So the time complexity would be either O of n or n log n, which depends upon the implementation you are doing. So because all the elements are in between 1 to n, you can just optimize it to O of n, but otherwise you can just simply implement the O of n log n solution by sorting it or using maps and all. And I'll be discussing this O of n log n solution in the so yeah, this is the code in C++. So we'll first of all taking an input of all the test cases. We'll call this function solve for every test case. Now inside the test case, we'll take in the input of n, and we'll also take in the input of the whole array. Now we're also pushing all the distinct elements inside this distinct vector and all the other remaining elements in this other vector. And this map is just used to keep a track of the elements if it's already been used or not. So we'll be taking an input. If the element is not used, we'll say that the element is not used and we'll put it inside a distinct one. Otherwise, if it has already been used, if it's a duplicate, we'll be pushing it inside the other vector. We'll sort all the distinct elements. We'll initialize our answer with -1. Now, for every element, we'll say that at the position distinct of I, put in the next element that we have. And we'll be taking the modulo with distinct dot size to prevent overflows. If like I becomes equal to distinct dot size -1, then it will take the zeroth element. So the last element like the would have the zeroth element, right? Now we'll run a loop from 1 to n, and if the answer has not been initialized, like that means it is one of the duplicates. So what we can do, we can just push it any random element from another vector and just pop it and then simply print answer of I. And in the end, we'll just simply give a line break for the next strings. And that's pretty much the whole solution. The time complexity is n log n because of this sorting step and the map used here. Now let us discuss the solution in Python. So we'll first of all take in the input of the number of test cases. For each test case, we'll take in the input of the n and the array. And inside this use, we'll put like all the elements that have already been used. So this is just to keep a track of distinct elements. Inside this distinct, we'll put on all the elements which are distinct, and inside this other list, we'll put on all the elements which can be duplicated. So anything which is not distinct. We'll run a loop for the whole array. Now, if the X has not been used, we'll say that it's being used for the first time and we'll append it inside distinct. Otherwise, we'll append it inside the other list. We'll sort the whole distinct list. We'll initialize answer with -1. Now, we'll first of all rotate all the distinct values and put them inside the answer. So answer of distinct of I would be equal to the next distinct element. And we'll just take modulo m over here. So when I is equal to m minus 1, this will become m minus 1 plus 1, which is m modulo m, which is 0. So when I is m minus 1, answer of m minus 1 would be distinct. Like answer of distinct of m minus 1 would be distinct of 0. And then we'll fill in all the remaining positions, and in the end, we'll simply print the whole answer. So for filling the remaining positions inside our answer, it's like our answer of I is equal to -1. That means it's not being filled by a distinct value. So we'll simply put in anything from the other list and pop the last element. And yeah, that's pretty much the whole solution. The time complexity is n log n because of this sorting step and the set being used over here. And yeah, that's pretty much the whole solution. I hope you liked it. Thank you for watching.